Hello engineers, welcome to the new video of the course, and in this particular video we are going to understand the concept of extrinsic semiconductor. So basically we are going to understand that why exactly we are dealing with extrinsic semiconductor, like what was the drawback that we were facing in case of intrinsic semiconductors, which I had already explained to you all guys, okay, and how we are able to overcome that particular issue with the help of extrinsic semiconductor. So this is the main agenda of this particular session. So let's start with the session, and what I will do is that I will just read each and every point, and after that I will explain you each and every point in detailed way. Okay, so let's start with the very first point, and it states that the conductivity of intrinsic semiconductors were very less at room temperature. So this is the most important point to notice. So at room temperature, if you could remember, out of 10⁻²⁻⁹ atoms, only one covalent bond used to break. Okay, only one covalent bond used to break. Okay, so therefore the electrons available for the conduction or in the conduction band, it was very less, right, at room temperature. Just remember this particular point. Okay, so let's suppose if your modern devices like your laptops, like ACs, or modern electronic devices like TVs and all, and even in fact your smartphone as well, if they were made up of intrinsic semiconductor, so we were not able to use those particular devices at room temperature, right? To operate those devices, we might need certain higher temperature, maybe 100 degrees Celsius, 150 degrees Celsius, provided if that particular devices were made up of intrinsic semiconductor. So that was the drawback of intrinsic semiconductor. Again I will repeat. See, let's suppose if your modern devices or modern electronic devices like TVs, refrigerators, maybe your smartphones, laptops, desktops, whatever that is, if they were made up of intrinsic semiconductors, then we might need to go at certain higher temperatures, maybe at around 100 or maybe 150 degrees Celsius, so that we might get enough amount of electrons, okay, or rather enough amount of covalent bonds may break at that particular temperature. Okay, so that was the drawback that we were facing in case of intrinsic semiconductor, right? So to overcome that particular issue, what we had done, we actually focused upon the extrinsic semiconductors, okay, or rather extrinsic semiconductors were introduced. Okay, so what exactly is an extrinsic semiconductor, right? So I had mentioned over here that certain impurities were added in the intrinsic semiconductor to get the extrinsic semiconductor. So it is as simple as that. That means what? Let's suppose if this is your germanium crystal, right? Germanium crystal, obviously this is my intrinsic semiconductor, intrinsic semiconductor. If this is my intrinsic semiconductor, okay, and if I'm adding certain impurities, okay, as of now we are not sure of what exactly those impurities are, but just for time being, let's assume that we are adding certain impurities in it. Okay, we are adding certain impurities in it, then whatever the result that we will get, that will be our extrinsic semiconductor. So this is the basic definition of extrinsic semiconductor. I had explained you in the very shorter way. Okay, so what is extrinsic semiconductor? It is nothing but when you actually mix certain impurities with some intrinsic semiconductor, or with the pure crystal. Okay, it can be a germanium, it can be a silicon. For sure it should be a semiconductor, right? When you mix certain impurities with certain intrinsic semiconductor, then whatever the result that you will get or that you will obtain, that is known as extrinsic semiconductor. Okay, great. I hope you are able to understand this. Great. So now let's proceed further. Yeah, so we had covered this particular point as well. Now this one states that a very small amount of impurities can increase conductivity of intrinsic semiconductors many times. Okay, so I'll come to this particular point, okay, in some time, but before that we'll focus upon this particular 2 points. So it states that the process of addition of impurities is called doping. The impurity atom is called dopant. Okay, so what does that mean? See, when you actually do this process or this procedure, okay, when you actually do this process or this particular procedure, see, that means when you are mixing the impurity with the intrinsic semiconductor or with the pure crystal, so this particular process is known as doping, right? It is known as doping. And the impurity atom that you are doping with this particular intrinsic semiconductor, it is known as dopant. So this particular atom which you are doping or rather mixing with this particular crystal, it is known as dopant. Okay, And let me read the next line. It states that, this line states that the impure semiconductor thus formed is known as doped semiconductor. So basically it states that the extrinsic semiconductor is known as doped semiconductor. The extrinsic semiconductor. So this one, whatever the result that you obtain or that you got, that is known as a doped semiconductor. Okay. Again, we will see each and every point that we had studied till now. So the very first point was, see, the conductivity of intrinsic semiconductor were very less at room temperature. That means what? Let's suppose if our modern devices like, our modern electronic devices like laptops, TVs and all, if they were made up of intrinsic semiconductors, then to operate those devices, we need to go at certain higher temperature, maybe at 100 and 150 degrees Celsius. So that going at that particular temperature was not at all possible, right? So to overcome this particular issue, we introduced one new type of semiconductor, that was extrinsic semiconductor, right? So what will happen in the extrinsic semiconductor? So what we were doing, we are adding certain impurities in the intrinsic semiconductor to get the extrinsic semiconductor, and this is what we can see. We are adding certain impurities. As of now, that is not our concern, that what those impurities are. We will come to this particular point as we move further and further in the course. But as of now, just remember, when we are adding certain impurities in the intrinsic semiconductor, or rather in the pure crystal of germanium or silicon or any other semiconductor, so that particular combination will give you certain result, and that particular result that we obtain, that is known as extrinsic semiconductor. Okay, so this is the exact definition of not exact but kind of definition of extrinsic semiconductor. Okay, and this particular process, when you are adding certain impurities in the crystal, this particular process is known as doping, and the impurities that you are adding, right, or the impurity atom that you are adding in this particular crystal, or that you are doping in this particular crystal, it is known as dopant. Okay, whereas the resultant or the result that you achieved with this particular process, it is known as doped semiconductor. Okay, great. I hope you are able to understand this. Okay, so now we will focus upon this particular point. This is the most important point, and this will give you the answer for this particular reason, right? Very small amount of impurities can increase conductivity of intrinsic semiconductor many times. Okay, just remember, even if we add very small amount of impurities in the pure crystal or in the pure semiconductor, so the conductivity will increase by very large amount. Okay, so just to give you a rough idea by what amount, so let me just write over here that, let's suppose if I am adding, okay, so let's suppose right over here in this way, one atom of an impurity, one atom of an impurity, one atom of an impurity, when added one atom of an impurity when added in 10 raised to 8 atoms of germanium crystal, okay, 10 raised to 8 atom of germanium crystal, and its conductivity increases by 16. What does that mean? Okay, what does that mean? So for that, just a second, yeah, let me just draw over a rough diagram over here. So let's suppose I have certain germanium crystal which has 10 raised to 8 atoms in it. Let's suppose I have 10 raised to 8 atom of germanium, 10 raised to 8 atom of germanium, and in this particular crystal, if I am adding one atom of impurity, one atom of impurity, okay, so whatever the result I will get, its conductivity would be quite high. So let's suppose whatever XYZ result that we get, oops, sorry, let me just show it in this way. I know this might take little time, but sorry, this might take little time, but it will help you to understand this particular concept in better way, right? So that's why I'm taking little time. So yeah, I'll take this one. So whatever the result that we will get, okay, so the conductivity of this particular crystal, it would be 16 times greater than this one. So let's suppose the conductivity of this particular crystal is 1 unit. Okay, as of now we don't need to focus upon what exactly it is. Let's suppose we'll take a random number. Let's suppose the conductivity of this particular crystal, it is 1. Okay, now when we add 1 atom of impurity in this particular crystal, or rather when we dope one atom, when we doped 1 atom of this particular 1 atom of impurity in this particular 10⁸ atom of germanium, so whatever the crystal that we get, so the conductivity of this particular crystal, it would be 16. So you just see the conductivity increases by 16 times just by adding 1 impurity atom, right? Now let's suppose if I add, let's suppose if I add hundreds or thousands of such atoms, impurity atoms in this particular crystal, so obviously the conductivity will increase a lot, right? By a lot of amount, right? So that's the advantage of, you know, going with extrinsic semiconductor over intrinsic semiconductor. Why? Because you see, now we can easily go in the conduction band as far as in extrinsic semiconductor is concerned, whereas if you see in case of intrinsic semiconductors, you know, at room temperature, the electrons which were available in the conduction band, that were very less, right? Okay, so that's the reason that why we introduce extrinsic semiconductors. Okay, and you know, lots of our modern devices, they are made up of extrinsic semiconductors only. Okay, so this was all about the extrinsic semiconductor, the introduction part. I hope you really understood each and every part, or each and every concept that we had discussed. Okay, but still, if you have any doubt, if you are facing any difficulties anywhere, maybe in this particular session or the sessions before this, so it's my request to you that you please ask me those particular doubts in the communication section. I will surely help you out there. Okay, so thank you for listening to me patiently. I'm ending this video over here. Thank you.